Alrighty, let's get started on this one, proving segment relations and angle relations. We're going to try to combine a couple of different sections here so we can kind of make sure we get caught up, and we're going to reinforce proofing as we go along. But I'm trying to get y'all introduced to the idea of proofing and working from there. So you're going to write proofs involving segment addition and congruence, and then write proofs involving supplementary and complementary angles, congruent and right angles. What does all that mean? I have no clue. But I will say this. For fourth period, you're going to get a bonus word. And that bonus word for today, you have to show me in the notes, is going to be astros. Okay? For fifth and sixth, I'll tell y'all in a minute, a little bit later. But each of y'all are going to have a different word. So for fourth period, again, it'll be astros. Now, here are Theorems 2.1 and Postulate 2.9. You need to make sure you have those down. We'll talk about before the test what you need to have, like how you're going to have all these theorems and postulates in front of you so it can help you take the test. Also, get this one, Theorem 2.2, properties of segment congruence. All right, so now let's look at a simple example. Forgot what I had. All right, so here we go. Given that AB, we're going to do a simple proof. Given that segment or line AB is equal to CD and CD is equal to EF, prove that AB is congruent to EF. Did I say equal? I meant congruent. Anyways, so basically we're trying to say that this right here, this one right here, the AB is the same as EF. Okay, so given, let's start off with a given. It is given that we now know AB, line AB is congruent to CD, and that CD is congruent to EF. Okay, then we can say by definition of congruence that AB, line AB, is equal to CD. That's the definition of congruence. And CD is equal to EF. Thus, since by the transitive property of equality, which you have from the previous day's notes, you can say AB is equal to EF, and then you can say by definition of congruence that AB, line AB is congruent to EF. So you kind of see how you have to work things a little bit, and the main idea is that I want to see y'all start reasoning and trying to get up to there. Now, like I said, for the main ones, I'll probably be giving you some ideas and you fill in the blanks. So this one looks like less of a test that you can say have multiple choice. For example, here we go. P and R, hold up, I can't say given Q is between P and R is between Q and S, proved and PR is equal to QS, prove that PQ is equal to RS. So notice here, now this one they didn't put all the givens together. That's okay, but you would have to fill in the blank. So notice here, Q is between P and R. That's given. Then it says, the second statement, PQ plus QR is equal to PR. Well, how can I say that? Well, we have a thing now with segment addition postulate, which is postulate, 2.9, and then we can go from there. Then it says R is between Q and S, which is another one of the givens. So we'll put given. And then, well, what does that mean? Well, same thing as like number 2, but this time I'm going to say QR plus QS, QR plus RS is equal to QS. That's by, again, the segment addition postulate. Then they add in the third given, PR is equal to QS. Then through substitution, I can get rid of the PR and QS by putting PQ plus QR, and QR plus RS. So I'm substituting, getting rid of those PRs and QSs and putting what they added up to, or what adds up to them. Then I can use the subtraction property to get rid of the QRs, because I want to get rid of QRs from both sides, and what I would be left with is that PQ is equal to RS, which is what we were trying to prove. But notice here, it was mainly fill in the blank, and you just had to kind of figure out from there. For the fifth period word, if I haven't said it already, the fifth period word is going to be loop. You have to write loop at the beginning of your notes. All right, now we're going to have some more postulates and theorems, and there's a ton. Postulate 211, the angle addition postulate, which basically says if some line is in between or some ray is in between an angle, if and only if it's like, say, the two angles that are formed equal the larger angle that the whole thing forms. And you can kind of see a drawing there, but you get the idea. Here's some more theorems. Now, technically, keep in mind this. Postulates are things that you can't prove. You kind of have to accept as true. So we're saying we can't prove this, but we should be able to prove theorems. So we have a conjecture, and we're going to prove them. Now, for most of y'all, y'all will be able to accept these as being true. Maybe I give y'all a short, easy one to say prove them, but we're going to accept for most of our theories that they're theorems that they're true. Now, keep in mind that if we were, say, in a more, like, say, in a pre-AB class, I might ask you to prove all of those. Anyways, supplement theorem, complement theorem, there you go. Here's some more theorems about the reflexive property, symmetric property, and transitive property. Here's some more theorems. You know, you're seeing a lot of theorems here. Make sure you're getting all these guys because you're going to need all these theorems. These might be helpful. The vertical angles theorem, it's going to come into play later. Vertical angles are congruent. Oh, hey, there's a theorem that proves that now. We've just accepted it. And then there's a bunch of right angle theorems, because why not? Now, look, guys, I mean, if you're getting all this, just these parts right here, that's okay. I mean, you don't need to have the whole thing. Now, if you want to have the whole thing, hey, more power to you. You're awesome. All right, so here's my last example, because I didn't want to do too much here. And you can see here, here's another proof. I'm going to make it fill in the blank for you and kind of go from there. By the way, the 6th period class, your word is green. All right, so anyways, we have here, according to this, line AB is perpendicular to line BC. That's given. So then that means that, say here, ABC is a right angle. And again, that is by definition of a right angle. Then the measurement, since the angle ABC is a right angle, then the measurement of angle ABC is 90 degrees. Definition of a right angle. Thus, if the measurement of angle ABC then is also equal to angle 1 and plus angle 2. That's like that, say, angle addition postulate. 211, there you go. Okay, then by substitution I could say put 90, put this in place of this, thus that's what I get that. And then by definition we have angle 1 and angle 2 are complementary, because if the two angles add up to 90, then they're complementary. Now, angle 1 and angle 3 are complementary. That's given, because it is telling you that it's given. Thus, angle 2 and angle 3 have to be congruent. Theorem 2.7, I didn't feel like writing that out, says that right here, where it says angles complementary to the same angle are congruent. So that I just didn't feel like writing that out, but I just put 2.7. So you kind of get the idea there. Anyways, I don't really want to go too far into this. We will cover this more in depth in class, hopefully, if y'all can, like, say, work with me. And that's it for today. Thank you so much for your time. Y'all take care. All right.